Welcome back again. In this video or in this today we are going to discuss one more example based on homogeneous partial differential equation. The previous example which we have discussed is an assignment question, and one more assignment question is we have solved simultaneous partial differential equation 2 days back, means the second that is last class and second last class. We have discussed 2 examples. Out of that, first one is the assignment question. Okay, fine. Now this is very easy one. As you know already, to explain this example we have spent half an hour. I shared a video how to find out the complementary function by the help of roots of auxiliary equation in the previous class. So now just look at, if you don't know you can ask me later, because you have to watch the video, that is very important, otherwise you need to wait for third model. Okay, we are discussing the same concept in the third model. Okay, fine. Now what we are doing is, just look at here, z is the dependent variable, here y is the independent variable, and as we know that we are discussing partial. Whenever the term partial comes, there should be a minimum 2 independent variable and 1 dependent variable. Here you can see only 1 independent variable, that is y, but it is also x is present, but it is, you cannot see here, but it is default, it contain. Like as I told the example already in the previous class, that when you are eating, the legs are not needed. It doesn't mean that you don't have legs. While walking, hands are not needed. It doesn't mean that you don't have hands. Likewise, similarly, x also contains, but it is hidden. So for that purpose, you should be very careful. So first what we are doing is, here you can see that a partial differential equation with respect to one independent variable becomes ordinary differential equation. With respect to one independent variable becomes ordinary differential equation, that dou becomes d square z divided by dy square minus a square z is equal to 0. Hope you are following the first step. What is the first step we have done? Since it is a partial differential equation, you can find only one independent variable here, and it is a homogeneous. As you know the definition of homogeneous, that each term containing either a dependent variable or its partial derivative. Here it's a dependent variable, its coefficient is a square, is a constant, doesn't matter. If there is a variable like x and y comes, it is a non-homogeneous, and here it is a derivative of a dependent variable. Now how to solve this equation? As we know that in the second step we are going to substitute here d square divided by dy square as capital D square. Okay, so then the given equation becomes, what about the given equation, student? This will become d square z minus a square z equal to 0. It is d square minus a square into z is equal to 0. We have taken z common in the right side. It is a procedure, we have to take right side common. Then this is called standard form of a homogeneous equation. You will read in the third model, don't bother about till that. So it is a homogeneous equation. So here we are writing the auxiliary equation again. What is the auxiliary equation of this equation? Is obtained by just replacing d by m. Replacing d by m, it will become m square minus a square and neglect the value of z, or if there is any term in the right side also you completely neglect everything. So this is called auxiliary equation, and this is a quadratic equation, isn't it? M square minus a square equal to 0 is the quadratic equation. So how to solve this quadratic equation, students? Just it is m square equal to a square, or you can use a square minus b square formula also. M square equal to, I have taken minus a square to right side, then m is equal to, it is plus or minus of square root of a square. If square goes to right side, it will become a square root. This is plus or minus square root of a square is a. So m is equal to plus or minus a means m value is a and minus a. The roots are different. What do you call it as? Roots are different. I told you in the last class, nature of the roots of quadratic equation. Roots are distinct or different, roots are equal, or roots are complex or imaginary. So based on the roots and which are different, how to write the complementary function we know already. So we write the dependent variable. What is the dependent variable here? Z is equal to, we are writing C1 e raised to first root, and what is the independent variable here? Which is y. We are always writing dependent variable in terms of independent variable. C1 e raised to ay plus C2 e raised to minus ay. This is called the solution of this equation only. But we are writing the solution of a partial differential equation. We have written the solution of only ordinary differential equation. To write the solution of partial differential equation, just concentrate, it is a dou square z by dou y square. If you want to get z from this, you need to integrate twice, isn't it? For example, just look at here, if you have dou z by dou y is equal to something, you have to integrate once, you will get the value of z. If you integrate twice, you will get z in this case. Okay, since it is a second order. Therefore, you need to integrate with respect to y twice. Integrate with respect to y twice means, what about the arbitrary constant? You please go back to the previous example that, so we have added the arbitrary constant as a function of y there. Just go back. Here, since we are integrating with respect to y twice, the solution becomes z is equal to, instead of constant c1, we are writing f of x into e raised to ay plus g of x into e raised to minus ay. Why these are f of x and g of x? You people already aware that when you integrate with respect to x, we are adding constant as a function of y. You know already. Similarly, here we have integrated twice with respect to y, means there should be a 2 function of x. So for more details we discuss later, right? Okay. So now this is the solution of this partial differential equation. So further, by using these conditions, we need to find out f of x as well as g of x value. So let us observe how to find out the value of f of x and g of x. First we are substituting z is equal to 0 at x is equal to 0, means you should substitute z is equal to 0 in the left side and x equal to 0 in the right side. So what will happen? X equal to 0. Now it is not x equal to 0 as per my view, because if you substitute x equal to 0, the value of f of x and g of x we don't know actually. So better it is a value of y. Later we can change. When z is equal to 0 at y is equal to 0, what will happen? Just look at y is equal to 0. Y is equal to 0 means 0 into a, 0. E raised to 0 is 1 and e raised to again 0 is 1. So it will become 0. Left side is 0 is equal to, you will get only f of x plus g of x, because both are 1 only. So you call it as some equation number 1. So next we have to differentiate z with respect to y here, isn't it? So to get the value of dou z by dou y, so you can differentiate z with respect to y. What will get? Dou z by dou y is equal to, okay, with respect to y, f of x is constant, differentiation of e raised to ay is, differentiation of e raised to ay is e raised to ay, again ay is a, okay, plus g of x into differentiation of e raised to minus ay is e raised to minus ay, again minus ay is minus a. Okay, fine. Now we can use the second condition. Substitute dou z by dou y is equal to 0 or a sin y. A sin y at y is equal to 0. So what will happen? Substitute here. Dou z by dou y is equal to what? Here. A sin y is equal to f of x. Again y is equal to 0. E raised to 0 is 1. 1 into a is a. G of x is as it is. E raised to 0 is again 1 into minus a is, this is minus of a. Okay. So further, in the right side a is common. What you will get? F of x minus g of x. Left side is a sin y. A and a get cancelled. Write in the reverse order or in any form, you will get sin y is equal to f of x minus g of x. Call it as equation number 2. So we have f of x plus g of x equal to 0, one equation, and f of x minus g of x is equal to sin y is the second equation. By solving these two equations, you will get f of x and g of x value. So how to solve these two equations? For finding f of x, we are adding these two equations. Add 192. Add equation 192. I am writing in the reverse order instead of, okay, first I am writing these two terms, then is equal to 0. Then we are writing these two terms, then is equal to sin y. So writing in the reverse order, f of x plus g of x, I have written the right side. What is the right side here? F of x minus g of x. Look at the right side of first equation, which is 0, plus right side or left side of this equation is sin y. So minus g of x plus g of x get cancelled. 2 times of f of x is equal to sin y. F of x equal to sin y by 2. This is by adding you will get f of x. Similarly, by taking subtraction, or you can just take, or that's also good, but we are doing for what? Take 1 minus 2. 1 minus 2 is, this is 1, right? F of x plus g of x. Take minus sign here, minus of g of x, minus minus plus, sorry, plus, this is f of x, g of x is equal to, this is 0 minus sin y. First we have added, and now in this example we have subtracted, plus f of x, g of x get cancelled, sorry, 2 f of x are get cancelled, you will get 2 times of g of x is equal to minus sin y, g of x is equal to minus sin y divided by 2. So we have got f of x as well as g of x. Finally substitute in this equation. Therefore solution is z is equal to f of x value is sin y by 2 into e raised to ay plus g of x value is minus sin y by 2 into e raised to minus ay. You can also take sin y by 2 common. What you will get? Sin y by 2 into e raised to ay minus e raised to minus ay. If I transform this 2 to here, what about this? E raised to ay minus e raised to minus ay by 2 represent? Do you have any idea about this? This will become z is equal to sin y into sin hyperbolic ay. This value becomes sin hyperbolic of ay. What is cos hyperbolic ay? E raised to ay plus e raised to minus ay by 2. Thank you. Any doubt regarding this? If you have any question, please feel free to ask.